Hello everyone. So today we are going to discuss the concept of complements. So how to find the complements among the number systems. Okay. So what is complement in the sense? The conversion of a positive number towards a negative number is called as a complement. So in binary number system we have two types of complements. One is ones complement and two's complement. So how to find one's complement of binary number and how to find two's complement of binary number, that we should going to see now. Okay. So what is the method? Suppose if this is your original binary number, if you want to find the ones complement of a binary number, then convert the value of 0 to 1 and 1 to 0. Okay, that will give you the binary representation. See, if this is the original number, and if you want to find the ones complement of this number, replace 0 with 1 and 1 with 0. That's it. Okay, just change the values. That will be your ones complement. Okay, simple method. Conversion of 0 to 1 and 1 to 0 will gives you the ones complement of the given number. Okay, then how to find two's complement? Two's complement is nothing but first you find one's complement and add 1 for that and add 1 for that, then you will get two's complement. See, this is one's complement and I added 1 at the last bit, then I will get two's complement. Okay, you know the rules of addition already. Okay, when you add 1 plus 1, sum will be 0, carry with 1. Okay, by using these particular constraints, you can add this, therefore you will get two's complement. Remember that always r's complement will be obtained by adding 1 for r minus 1. See, r minus 1, if you add 1 here plus 1, just a minute. If you add 1 plus 1 here, then what will come? This one will be cancelled and you will get same r. Okay, so in order to get r, first of all you should have r minus 1, and for this r minus 1 you add 1, and this one will be cancelled, you will get r again back. That is the process. First, if you want to find two's complement, first of I will find one's complement and then I will add 1 for this, then that will gives me the two's complement. Okay, clear? Now what about octal number system? Octal number system we will have 7's complement and 8's complement. How to find 7's complement? Suppose if this is example 3675, total number of digits are 4 in this number. So take 4 sevens and subtract the given number. You will get this as your answer, 4102. This 4102 is the 7's complement. For the 7's complement, if you add one more 1, you will get 8's complement. Okay, so this is the generalized expression. Please remember, this is the general expression. Okay, r's complement is equal to r minus 1's complement plus 1. Very, very important. Okay, please note that. So if I want to find 8's complement, first I need to find 7's complement and add 1. Then only I will get 8's complement. Okay, next. You can say the same example here also. But while adding 1, you should add to the last bit. Okay, don't add under 0. Why? Because the number is, this is the last number. Even though it is an integer fractional part, this is the last number. Okay, don't add here. You should add here 1. Be careful. Next. What about hexadecimal? Here also we'll have two different, 15's complement and 16's complement. As we know that for any decimal number system with base r, you will have two different types of complements. One is r's complement and second one is r minus 1's complement. Okay, by that this is r's complement, 16's complement, r minus 1, 15's complement. So how to find 15's complement? First, to find out how many number of digits are there. Suppose a b c d is the given question. You find 4 bits here. So write 4 15's and subtract the given number. You will get 15's complement. For 15's complement, if you add 1 like this, you will get 16's complement. Same format. Okay, clear? Please practice the complements. Why? Because these complements topic will be confirmly repeated in concept of subtraction. Okay, why? Because subtraction without these complements you cannot do. Until unless you know the complements, you cannot subtract the numbers. Okay, complements is the concept which comes again in your subtraction concept. Okay, without complements you cannot even simplify one step also. Without complement you cannot proceed in the concept of subtraction. Please learn them carefully. Okay, now we will see the binary codes. What are all the binary codes we have? Then what is a code? See, suppose when you are transmitting the data from a transmitter to receiver, or else if you are sending data from one place to another, definitely requires a channel for transmitting. So during the transmission of data within the channel, due to the presence of some noise or any other factors, there will be some data loss. So in order to avoid the data loss, or in order to prevent the data security, improve the data security, we will add some extra bits at your transmitter side, which are called as encoded. Okay, the process of adding extra bits at the transmitter side is called as encoding. And at the receiver side, they can be again decoded. Okay, by encoding and decoding process, we can improve the data security and prevent the data loss. So in order to encoding process, or in order to adding the bits, we will use some symbols. Okay, the group of symbols are used to encode them. So those symbols we call as an codes. Okay, the digital data is represented and stored in the form of groups or binary bits. Okay, clear? Now, so these codes are classified into several categories. First category is weighted codes. Second one is non-weighted codes. Third one is reflective codes. Fourth one is sequential codes. Fifth one is alphanumeric codes. And last one is error detecting and correcting codes. You can call this as an EDC codes. Very, very important. EDC codes. Okay. Now, so again, this weighted codes is classified into two formats. One is binary code. Second one is BCD code. Okay. These the part given in box are your examples. Okay, the types of codes which comes under this category. Okay, these are the codes which comes under this category. These are all the codes comes under this category. Like that, this box represents what all the codes comes under those respective categories. Okay, if they ask you to mention the examples of reflective codes, you can say these three. These three are the examples of reflective codes. If they ask you to write the examples of alphanumeric codes, these three will be the example of alphanumeric codes. Okay, this classification table is very, very, very important. Please note down this. Okay, now what is a weighted code? We will see one by one in detail what is a weighted code. In weighted code, each digit position of number represents a specific weight. As the name itself indicates, weighted code. There will be some certain weight. Okay. See, 8421 system in the sense 8421 are your weights. Okay. Likewise, 90 here 5421 means 5421 are your weights. According to these weights, you can write the representation of any number. Okay, see 93 is there. How can you write 9 in terms of 8421? When you add 8 plus 1, you will get 9. So under this 8 keep 1, under this last one you keep 1. These two are not necessary for us. Okay, see here, how will you write 9 in terms of 8421 system? 8421 system means when I add 8 comma 1, I will get 9. That's why under 8, under 1, I will take 1. And these two are not necessary for me, I will take 0. So 1001 is the representation of 9 as per 8421 system. That written here. Like 3, 2, 1. If you add 2 plus 1, you will get 3. That's why last two numbers will get 1 and remaining 2 are 0. Like that, you can make this also. The same 9, how can write in 5421 system? 5421 system, the same 9 can be written as, when you add 5 comma 4, you will get 9. So keep here 1, keep here 1. These two are not necessary, so keep zeros. So 1100 is the representation of 9 When you take 5421 scale, 5421 scale, see, 1100, like that, these weights help us in representing the binary numbers. Okay, next, what is non-weighted codes? Here, in the previous one, weighted codes, we will have certain weights here, but non-weighted codes does not assign with any weight. Okay, they are not assigned with any weights. Okay, the examples of this is XS3 code and gray code. Okay, very important. XS3 code and gray code are the codes which comes under non-weighted category. Okay, next, what is reflective code? The code is said to be reflective when the code of 9 is the complement of 0 and code of 8 is complement of 1. Like that, if the condition exists, then it is called as reflective. Okay, the code of 9 should be the complement of 0. The code of 8 should be complement of 1. The code of 7 should be complement of 2. So when you compare 9 comma 0, those should be complement to each other. When you compare 8 comma 1, those should be complement to each other. Okay, so 2421, 5211, XS3, these three are the examples for reflective category. Okay, and one more important point is 8421 system. This is the major scale we are using. Okay, we frequently use this code 8421. So especially I am writing here, the 8421 code is not reflective. Very important bit. Okay, 8421 code is reflective or not reflective means it is non-reflective. Okay, next, what is sequential code? In sequential codes, the succeeding code is one bit binary greater than preceding code. Sequential means they should come in an order. Okay, so suppose if I write sequential means sequence of numbers means 1, 2, 3, 4, like that you will write. When you compare two successive numbers, the second number will be one bit more than the previous number. 1 and 2 comparison means when you add 1 here, then only will get 2. Okay, the second number is one bit more than the previous number. The third bit is one bit more than the second number. The fourth bit is one bit more than the third number. Okay, that means the difference between the two numbers should be 1 commonly. That is I am saying here, each succeeding code is one binary number greater. One binary number greater means plus 1 than the preceding code. Okay, preceding means the previous code. When you add 1 for the previous code, the current code should exist. When that condition exists, then it is called a sequential code. Okay, the best example is 8421. 8421 is a sequential, but it is not a reflective code. Okay, 8421 is sequential code, but it is not a reflective code. Next, alphanumeric. Already name indicates alphanumeric. So combination of alphabets plus numbers. Numbers plus alphabets. It is called alphanumeric code. Examples are ASCII code and Hollerith code. Okay, ASCII code and Hollerith code. You know what is full form of ASCII? American Standard Code for Information Interchange. ASCII code and Hollerith code. These two codes are the best examples of alphanumeric codes. Next, the main important one is EDC codes. Okay, the same concept. When you are transmitting the digital information from one system to another, there will be an error occurring. What is an error? How error can be changed or error can be formed? Suppose if you are transmitting 0 1 0 from your transmitter, at the receiver side, if you receive only 0, 1, it means that data is lost. Why? Because here the number of bits are 3, here the number of bits are 2. So by seeing that one bit is lost during the transmission, this is one type of error. What is another type of error? Suppose if I transmit 1 1 0, at the receiver I will receive 0 1 1. So what is the answer of this 1 1 0? 6. What is the answer of 0 1 1? 3. That means when I transferred 6, I got 3 as my answer. That means this is an error. So what type of error is it is? Mismatching of the numbers. Okay, interchanging the positions. First bit came to last bit came to first. That is the thing we got at the receiver. Position of numbers interchanged so that the value is also changed. So this is one type of error we can see, and this is second type of error we can see. First one is data loss. Second one is mismatching of data. These are the two ways an error can occur in the digital transmission. Okay. Next. So in order to overcome this, we have some methods to follow. Okay. And now the codes which allows only error detection are called error detecting codes. Okay, the codes which are used to detect only the errors are called error detecting codes. And there will be some codes which allow both error detection as well as correction. They are called as error detecting and correcting codes. Okay, remember this point, very very important. The codes which allows only error detection are called as error detection codes, and the codes which allow both detection and correction of error is called as error detection and correction codes. Very very important point, this one. Okay, now you see here we have one more extra as BCD code. What is that? Binary coded decimal. So what is the difference between binary format and BCD format? Don't confuse that. Binary and BCD are same. Binary number, BCD number, both are entirely different. Okay, these two will be same up to a single digit number starting from 0 and ending from 9. Binary will be equal to BCD. Okay, see the values present in binary and the values present in BCD both are same. Okay, binary and BCD both are same up to 0 to 9. 0 to 9. From 2-digit number, these two will be differed. Okay, for 0 to 9, you will have both values same. And for 10, binary value of 10 is 1010, but the BCD value of 10 is this one. Nothing but BCD of any 2-digit number is nothing but you should write each and every digit in 4 bits. See, each and every decimal number is represented by a separate group of 4 bits. That is the method you need to follow in BCD. Okay, separate group of 4 bits. Okay, suppose if you take 10 in binary means 1010, but the same 10 in BCD means this 0 is written separately, 4 zeros, and this 1 is written separately as 0001. Combine these four, you will get 8 bits, and those 8 bits will be your answer. Okay, see, this one is different, this one is different, this one is different, this one is different. So up to single bit numbers, that means up to 9, these both are same. After 9, binary is different, BCD is different. How to write BCD? Each and every number. Suppose for example 654 is there. 654 in BCD means this 4 is to be written separately, 5 is written separately, 6 is to be written separately. Okay, remember that each and every digit should be written in 4 bits separately when it is a BCD number. When it is a BCD number. XS3. By the name itself, it is the XS3, adding of 3. So these are your decimal numbers 0 to 9. So what is the XS3 value of 0 means? Add 3 here. 0 plus 3 is 3. So XS3 value of 0 is 3. XS3 value of 4 means add 3 here. 4 plus 3 is equal to 7. Okay, just you add plus 3 for the given number. Suppose if you want to write XS3 for 12, don't write 12 plus 3 is equal to 15. You should not write this one. Why? Because this is a mistake. XS3 for a 2-digit number, 3-digit number is different. What is the XS3 for 12 means? you should add 3 for 2 as well as you should add 3 for 1. Separately, you should add 3. Then you will get 5 as your answer. You will get 4 as your answer. Okay, 4, 5 is the excess 3 value for 12. Okay, single digit means directly you can add plus 3 wherever you want. But if it is 2 digit, each and every digit should be added with 3. Suppose if you want to find the value of excess 3 for 145, 3 digit number 145. So you should take adding of 3 here, adding of 3 here, adding of 3. 3 bits are there, so 3 3 should be added. So we will get 8, we will get 7, we will get 4. So 4, 7, 8 is the excess 3 value for the given number. Okay, each and every number should be added 3 separately. Don't forget that bit. Next, see here, these are the examples what I have said. Okay, next, gray code. See, gray code in sense we need to convert the binary to gray and gray to binary. That conversion is important. Suppose if binary number is given, see 10110, binary is given. How to convert to gray? First, your process to be started with left side to right side. Okay, your process to start with left side to right side. And whatever the bit you exist in the first bit, copy the same. If 1 is there, write 1. If 0 is there, write 0. Okay, copy the bit as it is the first bit. Now perform the addition between the two successive bits. 1 plus 0, write the result here 1. 0 plus 1, write the result 1. 1 plus 1, you will get some 0. Only write your sum value here. Don't write carry value. Only write sum value. Next, 1 plus 0, 1. That's it. This is your gray for the given binary. Okay, what is the process? First bit is to be copied as it is, and then start adding bit by bit separately, and write down the results down. Okay, first bit is taken same and start performing addition between the bits and write down the corresponding results here. And when you add two ones, take only the sum value, don't take the carry value. Okay, see, discard the carry. When carry is got here, discard the carry. This is the conversion of binary to gray. Suppose if gray is given, how to convert to binary? Reverse method, how to find? See, if gray is given, how to find into binary? Okay, how will you find? The first bit is taken common, same. The first bit is copied as it is. Now, the result bit is added to the first bit, second bit. Okay, add these. So 1 plus 0 will get 1. Write the result here. Again, the result bit is added to the third bit. 1 plus 1. Write only the sum value. Carry is not taken. Again, result with the next bit. 0 plus 0. 0 plus 0 is 0. Okay, the process will be like this. First bit is copied as it is. Next result bit plus like this. It will be like this. Okay, crossly should be added. Okay, see, I have mentioned the arrows. You should add crossly. Okay, only take the sum value when you have two ones. Don't take the carry value. Okay, so when you see this is an overview. These are the decimal numbers. These are the binary values. These are your gray codes. These are your BCD codes and XS3 codes. Just have an overlook of all these so that it will be easy to analyze. Okay, so I hope the concept of complements and the binary codes is uh, understood by you. Okay, so please make a note of these definitions, and we will meet in the next video with a new topic, that is nothing but EDC codes. How EDC codes are helpful for us for detection and correction of errors. We will see with in detail explanation there. Okay, so thank you. and have a nice day.